We are Brady and Allison. We elected to do our final project on the physics of rainbows. More specifically, the question we were looking to answer was, why do rainbows always form an arc? We'll start with some basics. What exactly is a rainbow? I'm confident 100% of you know what a rainbow is. It's an arc that forms in the sky, usually after a rainstorm. They are arched bands of color, in short. They always form opposite the sun. Next, how do rainbows form? When a rainstorm occurs, there are millions upon millions of raindrops. When they are hit by light, they refract it, meaning the light shoots in a different direction. The more raindrops in the storm, the brighter the rainbow will be. All light that hits the raindrops is white light, but the light that leaves is a different color. This happens because white light is usually made up of bands of Roy G. Biv colored light. Each Roy G. Biv color has a different frequency, or wavelength, than another color, and each are refracted differently. When white light passes through a medium, like a raindrop, the colors of light are bent at different angles because of the different wavelengths, thus causing multiple colors to appear. Glass can do the same thing.
Longer wavelengths are bent at larger angles, and shorter wavelengths are bent at smaller angles. Red waves are bent at around 42 degrees, and violet waves are bent at around 40 degrees. The red waves are larger, and that's why they're on top of the rainbow. The violet waves are the smallest, and that's why they're on the bottom of the rainbow. All the other colors in the Roy G. Biv sequence are bent at angles in between 40 degrees and 42 degrees, hence the continuous band of color. They all fit right together. Now, the normal raindrop is in the shape of a sphere. This creates symmetry between the center of the raindrop refracting the light and the sun. If the viewing angle of the raindrop is between 40 degrees and 42 degrees, all the colors are visible. And a little secret for you. A rainbow is actually a full circle, with an angular radius of 42 degrees. Its center is on the anti-solar point, the point directly opposite the sun from the observer. The rest of the rainbow is hidden by the horizon. We can do a little bit more digging into the refraction using Snell's law. This is the Snell's law formula. It is used to describe the relationship between refraction and angles of incidence. It is used for light and other waves passing through a material, like water, glass, or air. The formula, sine theta 2 over sine theta 1 equals velocity 2 over velocity 1. Broken down, sine theta 1 is the measure of the angle of incidence, which is the angle of reflection. The theta itself in that is the angle at which a ray of light hits a raindrop. Sine theta 2 is a measure of the angle of refraction, and its theta is the ray's angle after entering the drop. The difference in the two thetas is the amount the light bends. Velocity 1 is the velocity of light through the air, and velocity 2 is the velocity of light through water. This formula can be used to explain in a more mathematical way why the colors are in the order they are. We hope this video was helpful to all y'all, and that you learned something new from it. Thank you for watching. Here are the sources we used for this presentation.